This recording is a recording for the two of the standards that are in the Module 2 test. It is for F.IF.2 and F.IF.7c. The original date of this was on the September 22nd, but because of problems, we are redoing it. So I just wanted to go over what these things mean and do some examples. So the two standards that we went over on that lesson were F.IF.2 and F.IF.7c. So F.IF.2 has, these are what we have to go off of. This is what all the standards that we are teaching you this year are based off of, like everything that we're teaching you or going over and grading you on is based off of. So this is the main thing that you're doing. So we're talking about two quantities and interpreting all these things. Specifically for this lesson, this is talking about quadratics. So we are looking for the key features of these quadratics. So that includes intercepts, increasing and decreasing, positive, negative, maxes and mins, symmetries, and behavior. And we don't have to do periodicity with these things. In fact, let me just go like this. We don't actually talk about positive or negative with these things, but there it is. So I'm going to do this little notification about what these things are. Little lesson about what these things are. I have three little graphs to show some of the stuff, and then we're going to go through what the all these details are for all of these graphs. In fact, I think I want to make these a little bit smaller. Wouldn't it be cool is if you were really taking notes and you could just do that with things and it wasn't on this thing? Anyway, so intercepts. Let's first start talking about intercepts. An x-intercept is where it crosses the x-axis. So I'm going to put x-axis. And it's in this form. There's a number, comma, 0. The y-intercept is where it crosses the y-axis. And it's 0, comma, number. So those are what the points look like. These four things are all intervals. So it's saying where it starts. Interval. And they're in brackets. And the number is where it starts. Where it starts to increase or decrease, comma, where it ends. Or where it stops decreasing. Or increasing or positive, negative. Now, specifically with this unit, we're not doing positive or negative, so I'm just going to skip over that for the sake of time also. But that's what you need to know. This is the basics. Max or min is a point. And it's going to go some x and then y. And then end behavior. In fact, I should have moved all this a little bit more because end behavior takes up a lot of space. And I think it looks the craziest. It's one of the easiest things to do, but it looks ding-a-ling-a-cuckoo. So we're going to leave some more space for that. I'm going to hold off on doing that one for a minute. So the intercepts. So we have 0, something, or something, 0, and 0, something. Those are the intercepts of these graphs, these quadratics. So we have, let's start with this. If I had this graph crossing the x-axis right here and right there, then I would say that the x-intercept, let me say that that was maybe back -2. This is the point -2, 0, and this is the point 0, 0. So then it's going to be at -2, 0. Sometimes they'll just simply say x equals -2. And 0. Oh, see, I'm going to run out of room. In fact, I'm going to go like this. I'm going to reformat this. Let's go. Yep, that's not going to work. Okay. 0, 0. And they might just put x equals 0. The y-intercept is where it crosses the y-axis, which also is 0, 0. And then we would put y equals 0. That's fine. Or even if the graphs are upside down like this, 1, 2, 3, 4, 5, 6. So that would be -6, 0, -1, 0. Let me change it so it's a different color so we know it's a different problem. Purple. So -6, 0, and -1, 0 are the x-intercepts. So -6, 0, -1, 0. And then for the last one, and then the y-intercept would be whatever that point is right there. I'm going to guess that that is 0, -1. 0, -1. And then you might have, these are not quadratic, but I just want to put this one on there just so that you can see the difference. So this one has 3 x-intercepts. So if that was 1, maybe 2, 3, 4, and maybe this is 0, 1, 2, 3, 4 also. Maybe that's -5. I don't know. Okay, so we'd have like -5, -4, 0, 1, 0. And the last one that we had is 1, 2, 3, 4, 0. And then the y-intercept looks like it'd be at 0, 1. Okay, so they're all just points. You could just put x equals. They basically mean the same thing. Increasing and decreasing. Increasing means it goes up as you're going from left to right, and decreasing means it goes down from left to right. So this is how we would write this one. So you can see this part. Let me highlight it, in fact. It is increasing right here. From that point right there on, increasing. Or this one is increasing right there. Or this one is increasing from there to there, and then it starts again and goes right there. So we write these in intervals. Since the place where this starts to increase is this number right there, which is -1, we would say it's increasing starting at -1, and it's going to increase forever. So we put infinity. This one right here is increasing. It was increasing always. And then it stopped increasing at that point, which looks like that was -1, 2, 3, maybe 3.5. -3.5. And then this one, which you don't have to do this, I just want to show you the difference that there would be 2 of them. So it's always increasing from -infinity. And then it stopped increasing. Looks like that's at -2. And then it started, and then we say a big U. It started increasing again at 3. And then will always increase. So that's what increasing and increasing, decreasing looks. Decreasing would be basically the same thing, it's just going down instead. So let me not do that color because it'll look like the same as the other one. So this is oops. This is also what I wanted to change. So decreasing, decreasing, decreasing. And then you write it the same type of notation. So it decreased. It was always decreasing and then stopped decreasing at -1. And same thing. Or you might write this, by the way, you might write this like x is less than or equal to, or less than -1. Well, this would be x is greater than -1. This would be x is greater than negative. Oh, sorry, less than -3.5. This would be x is greater than 3.5, -3.5, which you could write that as -3.5 to infinity. And then this one, you just have between the 2 and the 3. So this is, you would go -2 to 3. It was increasing. And you would write that as -2 is less than x is less than 3. All right, so that's increasing. That's intercepts, increasing, decreasing. Max and min is a point where it's the maximum or the min. So this point, let me change this color to the gray one. Max and min. Another word for the max and min, it's a point, is also called the vertex with the quadratics. So this point right here looks like it's the point -1, -1. So that would be the vertex for this one, -1, -1. The vertex on this one looks like it'd be -3.5, and then maybe 1, 2, 3. So it'd be -3.5, -3, or a +3 because it went up 3. And then this one doesn't really have a max or a min, but we'll skip over those. Those are a local max and a local min. I mean, they don't have a vertex. They're called a local max and local min. You don't have to know that for this quiz, so we're not going to do that. Biggest thing that I think is the most confusing, that looks horrible, is the end behavior. And so with the end behavior, you have to pay attention to a couple things. So it will always say something like, as x approaches, I prefer to start with -infinity. I think that the text or the strong mind might start with +infinity. So yeah, I'm going to start with -infinity. What this is saying, like x goes to negative infinity, this is saying if you looked at the left part of the graph, because we're saying, like, if we're looking all the way over on the x-axis, what is the graph doing? That's what it's saying. Like, if you're looking all the way to the left, is that graph going up or is it going down? So this part is, let me change this. So this is a fancy way of saying left. This is a fancy way of saying left. If you look all the way to the left, oops, that was supposed to be a T. Left, what is the graph doing? So let's finish writing the rest of it. F of x, and then I think in the text it says approaches, but it means the same thing. So if it says positive infinity, like notice there's no negative sign, this means if it's a positive infinity, that means it's going all the way up. Or a thing could go all the way down, and down would be negative infinity. So f of x goes to negative infinity. So this is a way of showing down. Or it might say the same type of thing, but then it would be positive. So actually, let me just show you all the different ways. So you could have left or you could have right. Right would be positive infinity. Just x. So left or right has to do with just x's. So this part talks about left or right. And then this part talks about up or down, like that half with the f of x. So x talks about left or right. The f of x or g of x or whatever thing they have talks about up, down. So let's look at this graph up here, the first one. These are both going up. So the left side's going to go all the way up and the right side is going to go all the way up. And so we would say as the left side, as x goes to negative infinity, the left side, f of x goes up, which is positive infinity. Or as x goes to the right side, so that's regular infinity, it also goes up, which is positive infinity. So this one, both of them are going down. So as we go to the left, it goes all the way down. And if we went all the way to the right, it would go all the way down. So we would say as x goes to negative infinity, f of x goes to negative infinity because that means down. And then the other one, as x goes to positive infinity, if you want to put the positive, you can, f of x also goes to positive infinity. So that is what those things mean. This one has a little bit of both. Like on this side, on the left side, it's going down. And on the right side, it's going up. So left side up on this one, right side up. So up, up. Left side down. Right side, even if it kept on going, it would go down. This one goes down on the left and right. I mean, up on the right. Oops. Up on the right. So this one you would write as x goes to negative infinity, f of x goes to negative infinity also because it's going down. And then as x goes to positive infinity, f of x goes also to positive infinity. So those are just different ways of saying the end behavior. It looks really confusing, and I think the way that they taught it was very horrible. So, okay, you're also going to have to know these things from a graph. So let me share with you what that would look like. Let me put in values for the table. This cooperates. Okay, so let's say we had this table that went like this. 1, 6, 9, 10, 9, 6. It's going to ask you all the information that we just found out by looking at those graphs. I think I need to move this up. It's going to show you all those things. Yeah, all those things by looking at those graphs. You're going to have to find out all that information just by looking in the table. And I think that could be really hard. So I'm going to show you how to make it easier. And then I'll do this other example too. Let me finish writing actually the numbers for this other one. Let's say that this was 32, 18, 8, 2, 0, 2. Okay. First, I like to identify where there is a maximum or a minimum. So let's do this. Let's do max, min. That's the number that's either you're looking at the f of x, and you're only going to look at what number is either the biggest, like bigger compared to all of them, or smaller compared to all of them. So I can see that all these numbers, we have a 10 that's bigger than the other ones in this table. And then it's kind of symmetric with that one. So there's a 9 here, a 9 there, 6 here, 6 here. So if you were to make a good guess about what number would go with 4, well, since 1 is up here, I would probably guess that 1 would be right there. So the max or min it is a max because it's bigger than all the other numbers, and it's at 1, 10. Or when y equals 10, you could say. Then because the 10 is the biggest one, then it's going to be increasing from negative infinity. And then we're looking at, I should put here, looking at the intervals. We're looking at only the x's, if you can see up there. We're looking at only the x's. So the biggest number right here was this 10, but it happened when x is 1. So it increased from 0 to 1 and then decreased from 1 to infinity. Then we can talk about let's talk about the x-intercepts and the y-intercepts. So x-intercepts, actually going to do that in a different color because you're going to have to use a different skill for that. X-intercept. We talked about up here that the x-intercept is a number, comma 0. Notice in our table here, we don't have anything that has f of x being 0. But I know it would probably be, we don't know exactly what would be there, but would probably be in here, right? And then if this was -3, it would probably be right there. So it's going to be, there's going to be 1 at about -3, like between -2 and -3. So let me change that. 1 between -2 and 3, -2 and -3. Again, we're looking at the x-axis, and then 1 between 4 and 5. The y-intercept, we've already got that one from up here. The y-intercept, we said, was a 0 common number, and that was right here. So this is our y-intercept. So y-intercept is 0, 9. And then, since I know that so if I were to graph these things, and I know that this has a maximum, I know it's going to be like a frowny face. I call it a frowny face parabola. And if it's a frowny face parabola, then the left and the right side both go to 0. So I would put that as, can I zoom in on that? Is that going to help? So as x goes to negative infinity, f of x goes to negative infinity. And then as x goes to positive infinity, f of x also goes to negative infinity because they both go down. Okay, make sense? All right. Or you would have one like this, and I don't know if I'll do all of them. If we had a table like this, I'm looking for something where it's kind of like symmetric on both sides. I see there's a 2 here and a 2 here, so that means that this right here has to be my max min. And since the 0 is smaller, then I can see that this is a min, and it would be a smiley face graph. So it's a min at 2, 0. It's increasing then It's increasing after 0. Increase from, from 2. So from 2 on, it was decreasing from negative infinity to 2, right? Because 32, 18, 8, 2, that's getting smaller. Then there's an x-intercept at 2, 0. There's only one of them. The y-intercept is already listed here also. It's at 0, 8. And then we would, since it's smiley face, it would be as x goes to negative infinity. F of x goes up. So that goes to positive infinity. And then this one would also go to positive infinity. A smiley face. Okay. So that's all of that stuff. That was so much information. I hope that made sense to you. We did it from a table. We did it with graphs. You can also use Desmos and do basically what we just did. So there would be things like, we'll say, you find the vertex of, or find the x-intercepts or whatever of, and then it'll give something like this. So let me show you. We have x squared, subtract 7x, subtract 18. So I have Desmos as an app on my device, especially if it works out. Okay, there we go. So x squared subtract 7x subtract 18. And we can find out all the information that we just wanted. So x squared subtract 7x subtract 18. So I can see from here, this is the nice thing about if you use Desmos. I can tap there, boom, x-intercept. Tap there, boom, x-intercept. Vertex, boom, there's the vertex. So 3.5 and negative 30.25. So just graph it, tap on it, you're done. You don't have to do anything fancy. This is also, if you want to download the app, you can. This is also just, you can open up another tab on your computer and it works super slick. All right. So we said 3.5. It was 3.5 and negative 30.25. So easy. Everything else on that standards evaluation was reading graphs of a height versus time of a rocket ball, a ball in the air, an arrow, whatever, and it's usually pretty intuitive, just kind of like reading the graph. Remember that it goes height versus time. Okay, so that was the key features with what we just did. F.IF.7c is more specific about when you have a graph and you need to get factors and zeros for it. So you have to know the difference between a factor and a zero. Let me just also give a little pro tip. They have in the lesson the difference between a zero and an x-intercept. They also have called it a root, but and they all have different definitions. For our purposes, it's just so much easier to consider them being the same thing, which I know that if other mathematicians were listening to this, they might be angry with me, but I'm okay with that. So if we have a factor like x plus 1 is the factor, the 0 for that is negative 1. And you might notice that to go from 1 to negative 1, it is the opposite. The reason why, and if you have a number in front of here, it makes it more complicated, but not too much more. The reason why is we would take that x plus 1, and we want to know when will that equal 0. So to solve that, I would subtract 1, and then I would get x is equal to negative 1. So they're very much related, and they are opposites. So if we had a graph like this, where we have this point at negative 1, 0, and this point at 1, 2, 3, 4, 5, 0, and we wanted to know what the factors were, we could see that they would be x plus 1, right? Because this was negative 1 over here, and it would be plus 1. And then x, the opposite of positive 5, is negative 5. And we could actually, if you wanted to, you could keep on writing those out, like x plus 1 multiplied by x subtract 5, and you could FOIL those out. You guys remember doing FOIL in Algebra 1? So first, outside, inside, last. So the first, outside, inside, last, I call this the claw. It would be x squared subtract 5x plus 1x, subtract 5, combine those like terms, and we would get x squared, subtract 4x, subtract 5. If you needed to. I don't think you really have to do that. Main thing you have to know is that these zeros are related to the factors. Or it might ask, when is this graph increasing? Again, go to Desmos. So we have negative x squared, subtract 2x, subtract 24. So I just edit the one that I have in here, if it will let me. Okay. So negative x squared, subtract 2x. 2x, subtract 24. So if I graph this and it wants to know where is it increasing, well, I can see that that's my max at -1, -23. So let me come back here. Okay, so my max, let me change the color. Desmos, the max is at -1, -23. Is that right? I have to go back. I forgot already because I changed color. Yep, -1, -23. And it was a frowny face graph. Frowny face parabola. So I know that it's going to be increasing from -infinity to that same point from the max, -1. Yeah, pretty cool, huh? Then the real world applications on the F.IF.7c had to do with words, not just pictures. So here's an example. A rectangular room is twice as long as the sum of the width and 5 feet. Represent the area of the room with a function and graph it. So let's remember, what is the area of a rectangle? Area of a rectangle is the length times the width. And it tells us that the length is equal to the sum, so I know that's plus, so that's plus, the sum of the width and 5 feet, but then it said it was twice as long. So this is twice. That was the sum. Okay, that twice as long as the sum of the width and 5 feet. So, and then our width is just the width. And so we would have that the area is equal to, I'm going to put the width first, multiplied by 2w plus 5. And we might have to keep on going with that and simplify. So maybe we could rewrite this as 2w multiplied by w plus 5. So we'll distribute that and make it 2w squared plus 10w. And then we can graph it in Desmos. One thing you might notice with Desmos, so it's 2w squared plus 10w. One thing you might notice with Desmos is there's no w's that you can graph with, but it's okay. Let me see if it works actually. So we had 2, and let me see if it'll let us do w. Nope, it says slider. Just use x. 2x squared plus 5x graph. So, and then you'd have to make sure what makes sense. Does it make sense to have a room that has a length that's a negative or a width that's anything negative? It doesn't. So really the only part of this graph that makes any sense for this problem is everything from the right, like that point right there. Let me get off from that point to the right. So yeah, there we go. Let's come back here, and it goes like this. That was 0, 0. So maybe it would ask, and then it could ask, like, what is the area if the width was 10 feet? So if the width was 10 feet, if w equaled 10, then the area equals, and you can do this in the graph, or you can write this, 2 times by 10 squared plus 10 times by 10. Oops, 10. So 10 squared is 100. So 2 times 100 plus 10 times 10 is also 100. So that's 200 plus 100. So that means the room would be 300 feet squared or square feet. Okay. I don't think you have to go into that detail with that problem, but you know, there's all sorts of stuff that you can do like that. Okay, so that is F.IF.4 and F.IF.7c. The lesson that should be today will be that one. So good luck.